Lecture 2 is about functions. And first we will speak about what a function actually is. You can find this on pages 23 up to 27. So as a statistician in practice, you will have to deal with observations. Observations come from some underlying process. We call this underlying process the input. And in general, it is unknown. Of course, observations are the output, and since you observe them, they are known. And the main question is, what can we infer from this known output about our unknown input? Can we recover it? Now, the simplest case is when there is a known relation between input and output. The simplest variant of this is called a function. So to introduce it, let D be a subset of the reals, and a function is defined as follows. You can find it on page 24. So a function f defined on the set D with values in the reals is a rule that assigns to each x in our set D a unique element y in the reals. And we denote this y by f of x. The set D has a name. D is called the domain of f. And of course we can also speak about the realized values. We denote it by f of D. So these are all y, real valued y, such that there is an x in our domain D, which is mapped to y. So with y equal to f of x. This set f of D has a name. It is called the image. Of D under the map F. Now with functions you can do all sorts of manipulations. You can add them, multiply them. You can find something more about this in paragraph 5 of the introduction, and I advise you to read it, especially the section on composite functions. Now let us give some example. Suppose that D is our whole set of real numbers, and we define the following function, which assigns to each x in D the output variable 2x. This is one way to denote it. You can also write f of x is equal to 2x for all x in our set D. Very often a function can be easily visualized by drawing a graph. In this case we set the input as the horizontal axis, the output is on the vertical axis, and when we draw the picture of this function, we see that we assign to value 1 we assign the value 2, to the value 0 we assign the value 0, and so we can draw the whole function, which we denote by y is equal to 2x. Now, is this a function? Yes, because to each input variable x we assign precisely one output variable y. Can we recover, in this case, x from an observed y? Well, yes. We can just choose one real valued y, we denote it by y prime on the vertical axis. Now how can we recover x from it, the input? We'll just go back and we get precisely one input variable x, which we denote by x prime. Now, since we can only go back for values in the realized set of values, so in this case it was easy because the image of the reals is in this case equal to the whole set of reals. Of course, this is a simple example where indeed we can recover the input from the output, but in general this is not the case. We will see this in the next example.